guys, and welcome back to another video. And we're going to be doing today type 1 improper integrals. So I'm going to explain what type 1 improper integrals are, and we're going to do a few examples, and we're going to think about the ways we can use it. So basically, a type 1 improper integral is simply an integral of a function where we start from a point and we go to infinity, basically, because the idea is it's improper because it's open-ended, right? It's not usually when we do an integration, right? It's going to be bounded by a or b. But in this case, a type 1 improper integration means it goes on to infinity. Or in the opposite way, it could also be from minus infinity to a. Doesn't matter. As long as this is what type 1 means. Type 1 improper integral just means that it's an open-ended integral that goes into infinity. And the way we express it is that we say that a type 1 integral, so let's say the integral from a to infinity, because infinity is not a real thing, right? So mathematically, the way we got to think about it is we want to say that this is equal, let's say dx first, is equal to the limit, and let's use another variable, let's say t, towards infinity, and the integral of from a to t, t to infinity, a to t of fx dx. Does this make sense? So as t approaches infinity, what is the integral? That is the way we find an improper integral. And this is simply because this is how mathematically we should write it, because infinity doesn't exist. Infinity is an idea, but mathematically it's undefined. And so that's why we have to use the limits if we want to express, this is towards infinity. So let's do a few questions and let's do something really simple. Okay, let's say that we're trying to find the integration from 1 to infinity of 1 over x. Basically, to this point, you've basically known enough about type 1 improper integrals, because all that means is the definition from a defined point to infinity. Because it's open-ended, it's called an improper integral, and there's going to be more types later, but I've only learned type 1, and so I'm going to make a video about type 1. And now you're going to see really quickly, it's really easy about how we're going to do this, okay? So if we want to evaluate this integral, what we got to do is we got to say this is equal to what I write over here, lim t towards infinity, or any variable you want, it doesn't have to be t, from 1 to t of 1 over x dx. Now all we have to do is evaluate, what this is first. So now let's keep lim t to infinity, but now this is going to be 1 over x integrates into ln x, right? Ln x from 1 to t. And so this is going to equate to a situation where it's going to be lim of t to infinity of ln t minus ln 1. Does that make sense, guys? And the natural log of 1 basically says e to the x, what is x for that to be equal to 1? And we know that x is going to be 0. E to the 0 is equal to 1. So ln 1 is going to be 0. And then ln t, so now we have to substitute t towards infinity in. So let's say this, basically we're not adding anything here anymore. Now it's just going to be ln of t, which now t is infinity. So the limit of this, where t approaches infinity, is going to be equal to ln of infinity. And ln of infinity, well, that's going to be equal to, let's ask yourself the question, e to the what is equal to infinity? Well, obviously it's going to be a very big number, right? E to the 100 is like big, and e to the 1000 is even bigger, right? So the bigger it is, so now we know it's e to the infinity would be equal to infinity, and therefore ln of infinity, right? This means that the answer, technically ln is like here, therefore this is here. E to the what is equal to infinity, e to the infinity. And therefore the limit of this towards the limit of this where t approaches infinity is going to be equal to infinity, and therefore undefined. Okay, now more things that you need to know. So if something is undefined, or sometimes you'll get, like, for example, like 0 over 0, for example, something like that. If the limit's like that, that means the limit doesn't exist. The limit doesn't exist in this case because it's undefined, right? And so in this case, we would say that limit doesn't exist for this. And the way we describe this integral here right? This doesn't have a limit. Same thing, because we just evaluated. We say it doesn't have a limit, and when it doesn't have a limit, we would say that this is a divergent, or you can think of it as diverging, a diverging integral. The function itself, if we had a big function here, this whole function, which is the whole thing here, is divergent. This improper integral is divergent. And divergent just means like something that, let's say we start at a point and there's two lines, right? Divergent would mean like the lines are going this way. And so it's slowly getting bigger and bigger and bigger. And so as we go towards the right, the area just gets bigger and bigger and keeps going into infinity. That's what divergent means. Sometimes you'll see something that's converging, right? And slowly it'll converge at a point here, and then it's a finite area. So that's going to be converging. And we're going to do a few examples where it's also converging. And so now you know, if you know how to evaluate the limit, right? And do the correct notation. And then if you see that it's undefined, you know that the limit doesn't exist. And if you know that it's undefined, therefore you can think of it as divergent. Okay, so there's a theorem that says, and this is a representation of the integral from 1 to infinity of 1 over x dx. I wrote 8 there, not infinity. So it just goes, we're looking for this. And 1 over x, this is equal to infinity. It's divergent. Okay, now there's a theorem that says that same thing, but for x to the n, right? X to the n. And when n is larger than 1, the value, the function, the whole integral, the improper integral, is going to be convergent. Meanwhile, if n is less than or equal to 1, then the improper fraction is going to be divergent. So let's try with 1 over x squared and 1 over root x. This is going to be quite quick. I'm going to go through it really quick just to show you what it looks like. So integral from 1 to infinity of 1 over, let's do x squared first. Okay, so now we need to rewrite it in terms of the limit of t to infinity, where this is 1 to t of 1 over x squared. We do this because this is mathematically correct. Therefore, this would be lim t to infinity of the integral of this. This is just technically x to the minus 2. Therefore, we increase the power by 1, divide by the new power, divide by minus 1 is just minus, and then x and minus 1 like this. And this is from 1 to t. Okay, now that just means that this is going to be lim of t to infinity of minus t to the minus 1. So that just means minus 1 over t. Minus, that's a plus 1 into x. 1 over 1 is just 1. There we go. And now that just means that if we sub the t that is infinity into here, it's minus 1 over infinity plus 1. 1 over infinity, any number over infinity is going to be 0, right? You're dividing by a large number. 0 plus 1. Therefore, the limit is equal to 1. And therefore, the limit exists. And 1 over x squared is convergent. Okay. And final thing, let's go from 1 to infinity with 1 over root x dx. Okay, so what we could do is we could, again, we do the same thing, lim t to infinity of from 1 to t of 1 over, this is technically x and minus 1/2. Therefore, this is going to be lim t to infinity of this is going to be increase the power by 1, so it's going to be 1/2 divide by the new power, divide by 1/2, it gives you 2 and 2 1/2, like this, and yeah, from 1 to t. And so what we have now is going to be lim t to infinity of 2, let's see, 2t to the 1/2 minus 2 times 1, the square root of 1 is still 1, so 2 times 1, which is 2. Okay, in this case, if we put t as infinity, then that's just 2 infinity to 1/2, which is still infinity. 2 times infinity is still infinity minus 2. Infinity minus 2 is still infinity, right? And so this is undefined. Therefore, the integral is divergent. There you go, and that proves the theorem, where if n is larger than 1, it's convergent. If it's less than or equal to 1, it's divergent. So now that we know all these things, what we could do is we can use two type 1 improper integrals to integrate something from minus infinity to infinity, right? So as I explained, an improper integral is from a bound, like a definite place to infinity. And in an uppercase, it could be from minus infinity to that definite place. So what we could do is if it's from negative infinity to infinity, what we could say is it's the integral if it's fx here. Then it's just the integral from negative infinity to some point of fx plus the integral of a to infinity. And these two plus together is going to give you to infinity. So let's do the integral of 1 over 1 plus x squared to infinity. From negative infinity to infinity, okay? Of 1 over 1 plus x squared dx. Okay, so we have to split this into two things. We split this into first the integral from negative infinity to, let's just say 0 for our own sake, plus from 0 to infinity. You see how minus infinity to 0 and 0 to infinity, they add up to make minus infinity to infinity, right? Okay, and this is going to be, we're going to rewrite it as mathematically, it's going to be lim t to the infinity of this from minus infinity to 0 of 1 over 1 plus x squared plus lim of t to infinity of 0 to infinity. This is lim, sorry guys, this is t to minus infinity of t. So t slowly approaches negative infinity, and this one is 0, t approaches positive infinity. And it's also 1 plus x squared. So let's do this really quick. If you look over here on the left side, you see that the differentiation of arctan gives you 1 over 1 plus x squared, meaning the integration of 1 over 1 x squared gives you arctan. So all this equation just simply equals to t to the negative infinity of arctan t, where it's from t to 0 and plus the limit from t of t towards positive infinity from and that's just arctan t, and that's from 0 to t. Okay, so what this is going to give is arctan 0. So if we look at the tan graph, right, the tan graph looks like this. Let's give it, I'm drawing it better. So the tan graph looks like this, where these points, like this is minus pi over 2, this is pi over 2, this is pi, and it goes like this. So so let's say we write this out. So this is lim t, gosh, it's a long thing to write. Lim t to minus infinity, arctan, so this is arctan of 0. Arctan of 0 just means at which degree does arctan equal 0. Arctan equals 0 here, that's 0 degrees. And so the degrees is 0 degrees or 0, and we don't have to write that. Arctan 0 minus arctan of t, and let's just write this out really quick, plus lim from t to positive infinity of arctan of t, so arctan of infinity. I'm gonna keep that here really quick. Arctan t, let's put arctan t first. Arctan 0 we know is 0, so we don't have to minus. So now we have these two things. So now we just need to think minus arctan. So lim t to minus infinity, we put minus infinity here. Arctan of minus infinity plus arctan of infinity. All right, so let's figure out what this is. So we see arctan of minus infinity. Well, look at this, right? Here, when the angle is minus pi over 2, the graph of tan goes all the way to negative infinity. So at which angle does the graph of tan go to negative infinity? Well, that's going to be minus pi over 2. So that's the answer for this. Minus negative pi over 2 plus, and let's look at the arctan graph again. When does arctan equal infinity? Well, let's look here. Here at pi over 2, the arctan graph equals infinity. And so what angle it is? It's pi over 2 plus pi over 2. And therefore the limit here, this cancels out to make a plus. So now we just have pi over 2 plus pi over 2, and that's going to be pi. And there it is, the limit, the answer to the integral of from minus infinity to positive infinity of 1 over 1 plus x squared is equal to pi. That's it, pi. And pi, and if the limit does exist, actually, and I just have to clarify really quick that this idea of splitting negative infinity to infinity with two type 1 improper integrals only works if both of these things are convergent. You can't have it where one is infinity and plus one is convergent. It's just not going to work. So to be able to split negative infinity to positive infinity into two type 1 improper integrals, both of these have to be convergent. And as we can see from our calculations, both of them are convergent, right? This one leads to pi over 2. This one leads to pi over 2. They're both convergent. And so this. So thank you guys for watching. Hopefully that was informative. I didn't really know the definition of type 1 improper integrals until making this video, so I'm very glad I made it. Basically, it just means from a definite point to infinity. And when you want to evaluate something from minus infinity to infinity, you can split it into two type 1 improper integrals, and that still works. All right, so thank you guys so much for watching. I'll see you guys in another video. Thank you.